the time. So, I'm happy that you're here and that you're not at the gorgeous Hansing session. Like 2 years ago, I also had my session in parallel with him, so don't know why. And we jump right into Scapy. Scapy is an interactive tool programmed in Python to forge, to craft, to modify, to send packets, to receive packets. And this is an example what you can do with Scapy. We're building the first line, it's split, that is better readable into 3 lines, but it's one command. So we have the variable pack, and this variable pack we fill with some layers. We're starting with the IP layer, define an argument, the destination address. So it's not one address, we have multiple addresses. You can see it with the asterisk in the 4th octet. Then the next layer, we separated the layers with a slash. We have a TCP layer. We use 3 arguments there, a destination port. So we're using 23 and 21. We have a source port. For the source port, we use a function or method. I'm not a Python guy, so please bear with me when it's called a method or a function in Python. I don't know. Sometimes there is a difference or not. I have no idea, but I will call it function now. We call a function random short, so it's the source port will be a random one. And the TCP header will have the flex, syn, ec, update, finish, push, set. So normally you wouldn't see such a packet in the real life. And all 3, the 2 layers, the IP and the TCP layer is now assigned to the pack variable. And the last line, we use the SR function or call to send out this packet or these packets, waiting 1 second. And when we get the answer, we will put it in the answer variable. When there are unanswered packets, we will put it in the unanswered. There is a typo in the unanswered variable. So that's a brief example of what you can do with Scapy.
I have not seen an unanswered thing before. What is put actually in the unanswered? The original packet that wasn't answered?
Yeah. So the answer variable, it's a list of packets where you have the packet which was sent out and the packet received. The unanswered variable is also a packet list, but only with the sent out packets. So, as you have already seen in the example, Scapy is about layers. And there are a lot of layers already implemented in Scapy, and as you've already seen, we stack them. So here we build another packet. It's only a virtual packet here. We haven't put it on the wire or into the air. It's just in the memory. And again, we have Ethernet layer, IPv6 layer on top of it, UDP layer, DNS layer. And you see sometimes we only call the layer method, so the Ethernet without an argument. Scapy is trying to put in most meaningful values for all the fields. So it's trying per default to have valid values for the field. When we switch to the console, and is it from the resolution? Because it changed. When I tested it yesterday, it was another resolution. Is it readable in the back, or should I increase it? Increase it. Okay. Then I have to. Sorry for that. So I'm starting Scapy. Here I'm using it on OS X. Scapy, you can run it on OS X, Windows, Linux. For Windows, you need the npcap library. For macOS, Linux, it's using the normal pcap library. And then we have our interactive UI, and we build this packet like I showed you just before. I've prepared already the example, so I've called the ether layer, the IPv6 layer, and so on, and assign it to the DNS packet. Now I have a DNS packet, and this DNS packet has methods or functions, and when we use the DNS packet show command, you can see how it would look when you would, not when you put it on the wire, as it looks at the moment in the memory. And you see, we didn't specify the type field for Ethernet. We just called the Ethernet function. And there you can see Scapy recognized at the next layer we have IPv6, so it put in the type 86DD. So it fills out values on its own and try to match the best possible way. But you can override it. How we will do it, we will see it later. When you look at the UDP header, for example, the checksum field has a non-value at the moment. But when we call the show2 method and scroll back, then you see the checksum field is filled. So Scapy also calculates checksums and so on to have valid checksums before sending out packets. So when we would send out the DNS packet, Scapy calculates the checksum and send it out. So the show2 commands show you the packet as it would look like when sending out on the wire. Then we can work with the DNS packet. And when we want to see what's inside at the UDP layer, for example, we can call the DNS packet UDP, and then we see all the layers inside the UDP layer. As we have the DNS as a payload of the UDP header, or of the UDP packet, or the UDP layer, yeah, that's why we also see the DNS. So you can call it with the name of the layer, but it's in real array, so you can also do a DNS packet 2, and then you see it, because we're counting from 0, we have the Ethernet layer on 0 index, the IP on 1, and then 2 is the UDP. So that's how you navigate inside a packet. Then, yeah, of course.
Possible to build up a packet with bad checksums, with wrong checksums?
Yeah, of course, we come to this. So, I've forgotten, I have, for every question, I have some sweets there. And Saki, you also, I'm trying my best. Yeah, you're welcome. So, now we want to see the Q type. Have a typo? No. Q? Yeah. 2 is UDP, and we have no DNS. I should prepare it. It's in the DNS queue. Very record. Sorry for that. So at the moment it's 1, it's A record, but we can override it and put in AAAA. Now we have the 28, so that's the decimal value for DNS AAAA query. It's a hint for the packet challenge, I guess. Sorry, oh, is it better now? Yeah. Okay, so we can modify values as we want. Then we can also, that as you asked, checksums. So we can just set it to FFFFFF, and now when we query it, we have this checksum. So it's not a valid checksum, but we can calculate, we can set it and send it out. So normally we would expect that another device receiving this packet would ignore it, but maybe not. So that's the way to use Scapy to test things.
Is it also possible for event CRC?
Yeah. You mean the CRC from the Ethernet? No. Not that I'm aware of.
To test the switches or
Yeah, no. No. When you set the checksum, but you want to have it reset it so that Scapy calculates it on your own, on its own, you can just delete DNS packet. UDP checksum. Yeah. And then we reset it, and when we look it up, it's now empty, it's none again. So that's a way to modify fields inside a layer. Yeah. Then there are other methods for such a packet. So we have the sprint. I've loaded and I don't have to type it. There's a sprintf method or function, like in normal C or whatever your preferred language, so printf. So you can call it and have destination IP is IPv6 layer destination field, and then you get the string destination IPs. So when you parse packets, sometimes you want to have it on the output, and then you can put out fields values. Then we have another, when you want to see all the fields inside this packet at the moment, you can call the ls function, DNS packet, and now you get all values, all fields, what type is it, and the current value. And the default value in the last column. And there you see the Ethernet layer doesn't give you the option to modify the CRC. So, no. Then there are another methods. DNS packet command gives you the command you would need to reproduce this packet in Scapy. So when you modified it, play with it, and you want to see, okay, how should it look like when I want to build it new with the command, you get the syntax for the current packet. Then we have another function, sometimes it's really nice, the PDF dump. which is not working here. I can show you in the slide. So the PDF dump file name, DNS PDF, for example, lists you this packet in a nice graphical view with the hex dump on the top, and you see all the fields with the values and where it is located in the hex dump at the moment. So for teaching purposes, this is a nice way to show where data is inside the packet. To run this, you need the tech environment on your system. Then we come to some other commands. So we want to work with the packet, and we build up, sorry. Now we build another packet, so with only IP layer, with the destination wireshark.org/30, and the IP protocol is a range, 0 to 255, so all possible values. And the next layer is a raw layer where we put in the string Scapy. And this is not only one packet, as you guess, because the destination IP or the destination address is a net mask. So Scapy resolves the name, so in this case, Wireshark walk to 104, whatever it's called, I don't know what it is at the moment, and use this IP address and put the mask /30 on it. So it should be 4 destination IPs. And the proto is a range, so we have then 4 times 255 packets. Specified with one command. And when we want to see how it would look like, we can call Wireshark A, and then it's opening on the wrong. Just a minute. So it's opening Wireshark, and sorry with the resolution. And you see now all these packets. And you see there we have 1,024 packets, so it's 4 times the 255. And you see now the first one is the first IP address with a IP proto of with a 0 option is the IPv6 hop by hop option, and of course Wireshark fails now to decode it right because it doesn't contain any IPv6 hop by hop option. It's just containing the Scapy raw string, but maybe you want to test something, so that's why you build such packets. You can also use the TCP dump command, and for this, like it would normally call TCP dump, but you can override the program variable and call, for example, tshark and specify the argument -v, and then when you call it, it's doing the same like we saw with the Wireshark. It's pasting this into tshark and gives you the result. So that's also ways to display the virtual packet A. Okay, when you want to see which commands are all available, there's the LSC command, the list command. And this gives you a nice overview which commands are available. And you see there we have the TCP dump command, the Wireshark command. T-Shark is not to call T-Shark. T-Shark is a similar call to sniff packets. So, yeah, the name of the command is not really good, but yeah. Then to see which layers are available in the default Scapy setup, you can run ls command for list, and you get a real long list for all kinds of layers which are already implemented. So EAPO, EAP, yeah, you name it, DNS, DHCP6. So there it's a long list. So there is already good work done, but you can extend it. How we do it, we will see later. Then we have now our virtual packet, which is only existing in memory, but we want to send it out on the wire. We want to see how other things react. So for this, we build another packet. So I prepared another packet. So again, A with the destination IP 1111, UDP, DNS, again, without any further values. Starting Wireshark. Where is my mistake? Sorry? No, it doesn't list any interfaces. The interfaces are empty. Strange. Okay. Okay, now we have our virtual packet A, and with the send command, send A, we will send it out. So when we look at the Wireshark, we should see one packet. As it is a valid packet, we also get the reply. Okay, we get the DNS error because the DNS itself was not really valid, but it was a valid IP and UDP packet, and the 1111 gives us a reply. So that's the command to send out packet. Just send A. When recognized, we're starting with the IP layer. So we didn't specify the Ethernet layer. When we want to work on the layer 2, we have to use another command. So now we have the packet B with only Ethernet header. And to send this out, we need the send B. Send PB command. And when we switch to the Wireshark, so now we need another filter to see it. Not IP and IP6 and yeah, thanks. So, and now when we send it out, we should see it here. Here it's also a malformed packet, of course. We only specified the Ethernet layer without any further data. But to work on the layer 2, you need the send P command. To work on the layer 3 upwards, you need the send command. So that's a different, yeah. No, it has a. You get to, sorry. Yeah, it's using when we will switch back to the A and we recorded. So, of course, it has an Ethernet header, but yeah, but it's then yeah, from the operating system more or less specified. So when we send out the packets, but sometimes we want to have the reply also in Scapy then. For this, we use the SR command, the send receive command. Send receive A, and then Scapy sends out the packets, has a filter in the background where it's looking for the reply, so it's sniffing and looking for the reply, and then you see we get, we've got one result, one UDP back, UDP packet back, and we can call it N and now we have the answer variable, and there is one packet inside, and this is a packet list. So when we specify the index 0, it's showing us the packet we send out and the packet we received. So the first line is the packet which we sent out with the values we've set, and the second, starting from the second line, is the packet we received. And now we can work again with this packet, modify it. So when you specified the index, so it's the first packet that the first pair, packet pair, and we want to have the second packet in this packet pair. We can specify with the 0, 1, and then we get only this reply. The layer 2 has the same, there is a SRP, so for the send receive P for layer 2. Okay, that's how you work with packets, navigate the layers, sending them out, receiving data, and so on. So, switching back to the presentation. Yeah, of course, you can build normal ways. So this is another example. I had problems with the timestamp option with my server. So you build a normal valid packet. Here it is a normal TCP SYN packet where you set a timestamp option, and we assign this to the NCTS variable, and with the SR1 command, we send it out. And the SR1 is only taking the first packet which coming back. So we're only interested in the first reply, and we get this with the SR1 command. Then maybe we want to have our virtually generated packet saved to a PCAP file. There is the write PCAP command where we specify a file name and specify which packets to save. So the packet equals ANS. We have the ANS packet list, and this is now in the foobar PCAP file. So that's a way to save your packets inside a normal PCAP file. For saving, you can only use PCAP. not pcap-ng at the moment. To read, there's the read pcap command. We read in the radius pcap-ng file, count 100, so we read only the first 100 packets, and these 100 packets, we are assigned this to the foo variable. So we have now a packet list called foo with the first 100 packets of the pcap-ng file. So for reading, we can use pcap and pcap-ng. For writing, only pcap. Then there is also the sniff command implemented. As you may guess, with this you can sniff packets, and you can specify the interfaces, so you can sniff on multiple interfaces. Here in this example, we're using the EN0, EN1 interface. We put a normal Berkeley packet filter, like you have it in the Wireshark, the capture filter. And for every packet we receive, we're calling a function. In this case, we take the packet and call the summary function. So maybe it's easier when I show it. Load 135. So now we need so I should no ICMP packet coming in at the moment. Yeah, okay. Now you see that for every packet Scapy receives, it's calling the summary method, and the summary method is to list the layers inside this packet with the values. When you started the sniff and you want to, and you saw, okay, there's a packet in there, I'm interested, you always have and you didn't specify a variable to put in the output there, you can always use the underscore virtual variable, so foo equals underscore, and then the foo variable has the output of the sniff command. So the underscore is a virtual variable where the last result of your last command is in there. Okay, so then we come to, that was how packets are handled. Then Scapy has, of course, a configuration, and you can see it with the conf command, or the variable in this case, and you see all kind of variables defined. For example, the iFace is the interface, the default interface Scapy using to send out packets for, especially for the layer 2 things. That's where the iFace is needed, because it has to know if it should send it out on the EN0 or EN1 interface. And this is the default value, and you can override this, of course. So with the iFace EN1, then it would use the EN1 interface to send out packets. But you can override it in each command, of course, but this is the default value. Then another thing in the configuration which is important, Scapy has an own routing table. So when starting Scapy, Scapy grabs the normal system routing table and put it into the conf root variable. And then this was my routing table when I started Scapy on my system. Now when I change my network on the system, connect to another network, Scapy has still my routing table from the beginning. So that's what you have to keep in mind, that when you're changing network and your routing table changes on the system, to get Scapy to the new routing table, you have to call the conf route resync command. And now the routing table of Scapy is the same as on your system. Why it's a routing table on your own? Because you can modify it. So when you want to have a route on your own, then you can put in the conf route add command, and we insert the route for the 10.10.10/24 network to the gateway 1234. When we now look it up, you see the second line is our own route, but this route only exists in Scapy, so it's not affecting your operating system, it's only affecting the Scapy operations. Of course, you can delete it afterwards, or just do the resync, and then it's gone again. Okay, so that was the part how Scapy is working. So now, why we want to use Scapy? So use cases. One use case which is implemented in Scapy is a Traceroute, and it's similar to a normal Traceroute, but it's acting a little other way. We can specify multiple destinations. For example, here we have Google.com, Wireshark, org, DuckDuckGo.com. The TTL, so how many hops we want to test, is 15, and we have 2 destination ports. When we run this command and the output is assigned to the trace variable, then we can call a graph command for the trace packet list, and that gives you then a nice graph how the TCP, the trace route look like. So you see the 3 destinations with the 2 ports, and you see that the first 3 hops were the same, and then the 4th hop was already different for every destination. It's interesting, Wireshark org is the shortest one, Google is the left one, and DuckDuckGo the right one. So you see there was also different hops for the different TCP ports, and Google on the last 2 ones, and DuckDuckGo starting from the 9th one. So that's a nice way to see it. Another, what you have to keep in mind, Scapy sending out all packets at once. So it's not like the normal Traceroute where you send 1 packet out with the TTL0, waiting for the reply, sending out the next packet with the TTL1. Scapy sends out all these packets at once. So TTL1, 2, 3, and so on, to every destination, to every port at once. So another thing you can do with Scapy is fuzzing. So when you want to test your application, you're writing, for example, NTP server, and you want to see how your NTP server reacts on non-specified values, then you can use Scapy. You're building your packet, the IP layer, the UDP layer, and then for the NTP layer, we put this into the fuzz command. And when we call this, so we have here our fuzz command for the NTP header, and when we send out these packets and we look it up in Wireshark, you see there are a lot of NTP packets, 189 was it, and every one looks different inside the NTP header. So sometimes the values are valid, but the state doesn't match. Sometimes it's malformed packets because it doesn't make sense. But that's what you want to do with the fuzzing. You want to see how your application reacts on different packets, if it crashes or not. And that's one example where you can use Scapy. Another example I have here with fuzzing, you use the random calls or commands to generate random numbers. So here we sending out .q in .q in .q packets, and we want to see if the switch is handling this right. So, and the VLAN tag number is always a random number.
Say one of these packets makes the notification of the switch crash. Can we know which packet may crash, or do we just know it crashed on
yeah, you then have to, you can not only use the send p command, you can use the send receive command and document each packet so you have it in a variable. And then, of course, you have to get the timings right to see where it crashed, and then, yeah, smaller the size, replay the packets. As you have it in the variable, you can replay it every time, and yeah, and then you have to dig inside where it's starting to crash.
So you can make it like so that there's only one packet per second for
Yeah, of course. Yeah, yeah, yeah. Also, as long as the last one. Okay. So another example where you can use Scapy is for developing. So especially the core developers when they're working on new dissectors, and they're missing a packet, or when they are working on bug reports, and the bug reports list not the packet you want to have to test it, then you can build your own packet. That's an example I've used to implement the ICMP extended echo RFC. And yeah, with the raw command, you can specify then the hex values and build your packets how you want to use them. And then you can test your dissector if it's working correctly or not. That's another way to use Scapy. Then, of course, where Scapy is in use is to attack or to do pen tests. This is an example from the RIPE 77 meeting last week or 2 weeks ago, where Henrik, however it's Gramschoy also, presented a tech for VXLAN, and to bring a proof of concept, he used Scapy, and you see that's a snippet of his code. He built his VXLAN packet with the Ethernet header, the IP header, the UDP, and so on. And with this, he building his attack and see if he can escape VXLAN or inject packets into VXLAN. So that's one great way to use Scapy to do pen tests. Another example for pen testing, it was a talk from Artem Kondrenko or so on last CCC Congress. Talking about CCC Congress, if someone has an Angel voucher for the certified C3, give it to me. Thanks. There was an advisory by Cisco where they said, okay, this model has a bug inside the SNMP MIP, whatever it was, and then he tried to find the bug, And he built packets, build the .65 times 100, so he has 100 AAAs, send this packet to a Cisco switch, and waited to crash, for the crash of the Cisco router, and then he was able to spot the buffer overflow with the backtrace and the AAAs. Normal ways to spot buffer overflows with the AAAs. And for this, you can also use Scapy. Then you can integrate it into your Python programs. As it is implemented in Python, you can use it as a module in Python and build your own programs then. Here we import the Scapy module, calling the Python random integer method, build our packet, and with this we build a TCP handshake. So we build our SYN packet, sending this SYN packet with the SR1, assign this to the SYN ACK variable, and sending out the ACK, where we use the SYN ACK sequence and put the +1 to it, and then we send it out. So with this, you can build a normal TCP handshake or whatever you need. When you're doing this, please be aware that your normal operating system doesn't know about your SYN you send out, so it would reset this SYN ACK. So that you are faster or that the reset of the operating system is not getting sent out, you have to drop it when using IP tables or packet filter or what kind of firewall you have on your operating system. Then the Python integration, as I've said, you can extend, of course, Scapy on your own. This example is here to show you how to send, to use DNS over TCP. We built own packet class DNS TCP, where we're using the DNS layer and adding the field length field to it. And then we're using the normal operating system socket to build up the TCP session. So we don't care about the TCP handling. We just want to have the TCP socket, and then we can use the SR1 function again to send our packet inside the established TCP session. So sometimes it's necessary to have a TCP session, but you want to do the TCP handling, you can use a normal socket and then go on with this. There are a lot of other very nice usages of Scapy. It's the Python networking hacking toolkit, which implements some ARP spoofing, ARP ping, whatever you want to mention. With Scapy, there's an implementation for HTTP. There are some nice examples where one guy is doing code injection with Scapy. Yeah. So there are a lot of good usages for Scapy. Some things which are not very well documented, that's why I put it here. The contrib directory in the Scapy source code provides some additional layers. So, for example, the LACP is not implemented in the core Scapy, but it's in the contrib directory, and with the load contrib, you can then have the LACP, or there are lots of other protocols in the contrib directory. When you're working with the interactive Scapy, I would recommend to install IPython. With IPython, you have the tab completion. So when you have DNS packet dot, and then tab, and you see all the methods, variable, and so on. which are available. That makes lives much, much easier, especially at the beginning. And you have the history, like I used it with the load command. That's the thing which is implemented in IPython. So with IPython, it's much, much easier. Yeah, and of course, more information is at scapy.net. Then there are some other similar tools. The first one is a fork of Scapy, the Camini, or don't know how to pronounce it. Previously, it was called Scapy 3 because original Scapy was only implemented for Python 2, and someone wanted to have it for Python 3, so he started a Scapy 3 fork, which is now renamed to Camini. I haven't used it. I'm still at the original Scapy, and yeah, I have no reason to switch, but others prefer the Camini. Wire edit by OmniPacket is also a tool to modify packets or to edit packets. Then, of course, it's a deprecated feature of the GTK UI from Wireshark, where is a packet editor included, and of course your hex editor of choice. Then, yeah. Ah, okay.
Because you mentioned wire editor and this tool a little bit, and I have sometimes use cases, for example, to anonymize some fields like an IP address of an existing PCAP, whatever.
For anonymizing, use Jasper's Trace Wrangler. I'm not sure if he has a session about Trace Wrangler. Tracewrangler.com, is it, I guess? Tracewrangler.com. It's a tool by Jasper, which is the perfect tool to anonymize packets.
So Scapy is not made for this.
Yeah, of course you can do it, but it's a lot of work to do, especially when you have thousands of packets inside a PCAP. Yeah. You can do it. You can anonymize any field you want, any byte you want. This is not possible with Jasper's tool, but with Jasper's tool, you're much, much easier to go to anonymize IP addresses and so on. Yeah. Trace Wrangler. Yeah, at the application layer, so we haven't Jasper here, but as far as I know, you can cut it, so you slice your packet of the 80 bytes or so, and you can replace the payload with a static string replaced by whatever, and you can, yeah, that's, I guess, zero it out, yeah. But you cannot modify the application layer and replace some specific values with another value. Yeah, for this, then when you need to replace some specific fields inside a specific packet, then Scapy is maybe the better way to do it, or your hex editor of choice. Yeah. Of course. Yeah, you can build frames as long as you want. If you can send it out on the wire, that's another thing. But for to testing Wireshark or so, you can build your virtual packet and save it in a PCAP file, of course. Yeah. Yeah, it's depending also on the PCAP, so the MPCAP, and so like Thomas said, last session, if you can eject packets depending on the chipset and so on. But when it's supported, you can send out this also on wireless networks. Okay, then these two guys are really great contributors. So the first one is missing words. The guy who established Scapy, Philippe Biondi, also. I'm not French, so I have no idea. And the other guy is also great guy who contributes a lot to Scapy. So thanks them too, and of course the Wireshark community. So, any other questions? There are 2 chocolates left. Then we're, yeah. Once a month or so, of course. So I'm using it quite often, not as often as Wireshark or so, but at work I'm using it to test things here. Okay, then thanks for being here and enjoy lunch.